In this example, he's talking about find the total impedance between the A-B terminals. So here I have A and B terminals. So first thing we need to know which elements are in series and which elements are in parallel. This is look like a ladder circuit. Always start with the element which is far away from the open terminals or which is far away from the source. So always start with from J2, because if I start with the 2 ohms, I don't know whether this 2 ohms is in series with something or parallel with something. But if I start from minus J2 here, I can clearly see this 4 ohms is in series with minus J2. How do I know? If the same current is passing through both elements, we know that those two are in series. So 4 minus J2, both of them are in series. I'm going to name this as Z1, impedance 1. Okay, I'm going to label that as Z1. Now that Z1 is in parallel with plus J4 ohm. How do I know that? Because this Z1, impedance 1, Z1 starting terminals and J4 and the impedance ending terminals both are the same. So if they both are starting at the same node, ending at another node, then those elements are in parallel. So these two are in parallel. So the parallel combination is 4 minus J2. It's just like resistors. Everything is in ohms. So you need to do it as just R1 times R2 over R1 plus R2. Same thing, Z1 over Z2 over Z2, Z1 plus Z2. So 4 minus J2 plus J4. So here I'm going to multiply in the numerator. It's going to be J16 minus J square 8 divided by 4 plus J2. Now I know that minus J square is always 1. Positive 1, J square equal to negative 1, minus of J square equal to positive 1, J square equal to negative 1. So this value, let me label this as something like Z3. So Z3 equal to, so Z3 is all of this impedance, the whole thing. Z3 equal to 8 plus J16 over 4 plus J2. Okay, so 8 plus J16, that value is 17.88 at an angle of 63.43. So what I did here, I converted rectangular format into polar format divided by same thing. 4 plus J2 is going to be 4.24 at an angle of 26.56. Again, I make the conversion from rectangular to polar, because when we are dividing two numbers, polar format is a lot easier than the rectangular format. So 17.88 divided by 4.24, that will give you around 4.21, and the angles are going to be subtracted. So 63.43 minus 26.56. Now this impedance, so this value is, I have 4.21 at an angle of 36.86. That's my Z3. Now Z total or ZAB equal to Z total equal to, basically we can clearly see the 2 ohms is in series with Z3. So we'll end up with 2 ohm and Z3. So those two are in series. So 2 plus 4.21 at an angle of 36.86. Now we're adding two numbers, so make sure both numbers are in rectangular format. So 4.21, when you convert that into rectangular format, it's going to be 3.374 plus J 2.52. So I have Z total equal to 5.374 plus J 2.52. We'll end up with 5.935 at an angle of 24.12 ohm. You can leave it in the rectangular format or you can convert it into polar format. Here I gave you answer in both formats. Next example. In this example, he's asking us to find the current passing through the capacitor reactance. So he's talking about find I1. this is a simple example. In this example, I mean, all I need to do is use the current division rule. So I know this is a current source. How do I know it's a current source? I mean, yeah, I have the arrow, and at the same time it's AC current source. How do I know that? Since there is an angle of zero angle, because of this zero angle. Okay, sometimes you might see a sinusoidal waveform inside it. That indicates that that's a AC. Okay, so everything is in ohms. So everything is in ohms here. I can use the current division rule. So if everything is in ohms, basically it is frequency domain. The circuit is in frequency domain instead of time domain, and this given current is RMS current. Okay, so I'm going to use the current division rule to find the current. So I1 equal to total current multiplied by, so here is my total current, I total multiplied by opposite impedance. So opposite impedance is nothing but whatever the current comes here, it's going to split in two branches. So we need to look for the opposite branch. So the opposite branch impedance is 20 plus J10. So let me label this as Z1, opposite impedance over total impedance. The total impedance is Z1 plus minus J5. You shouldn't include 10 ohms because that is not part of the current division. So whatever the total impedance I'm talking about, only these two branches. So Z1 equal to 20 plus J10 divided by 20 plus J10 minus J5. So I1 equal to total current 5 at an angle of 0 and times 20 plus J10 divided by 20 plus J5. This is going to be, I mean, convert everything into polar format because we are doing the division. Whenever you are doing division, polar format is better. 20 plus J10 is going to be 22.36 at an angle of 26.56, and 20 plus J5 is going to be 20.6 at an angle of 14.03. Now I1 equal to, you just do the divide, 22.36 divided by 20.6, that is going to be 1.08, and subtract the angles. 26.56 minus 14.03, we will end up with 20.56. okay, and both of them in polar format. The total current is 5 at an angle of 0 and the impedance. So the multiplication is going to be 5.427 at an angle of 12.56 ampere. Okay, you might have a question here, how come my total current is only 5 amperes, I end up with more than 5 amperes here? That could be because here I have two sources, two energy storage elements. One is inductor, another one is capacitor. So there is a possibility of current coming from this J10 ohms too. Okay, so that could be the reason we end up having extra current. Here is another example. In this example, he gave us V of t in time domain, I of t in time domain, and he's asking us to find the impedance. To find the impedance, impedance is always Vrms over Irms. Okay, it is always RMS values, Vrms over Irms. So I'm going to convert V of t into phasor format. So before doing that, make sure our omegas are same. If omega is different, we cannot do this. Make sure omega is same. So in this case, omega is same. So our Vrms is going to be 200 at an angle of 30 divided by square root 2. Okay, because this is the maximum value. This look like Vmax sine omega t plus theta. So that 200 is the maximum value. I converted maximum value into RMS. So that's going to be 200 divided by square root 2, and that 30 angle is coming from there. Same thing with IRMS, which is 10 divided by square root 2 at an angle of minus 60. So 60 came from here. Now, so square root 2 get cancelled out, and 200 divided by 10, it's going to be 20 at an angle of 30 minus 60, which is going to be 90. So 20 at an angle of 90 degrees. So we know that 20 at an angle of 90 is nothing but J plus J 20. So you can say 0 plus J 20 ohm. That is the total impedance. Here he's also asking us to draw the vector diagram. The vector diagram is always drawn for the voltage and current. So here you have V of t equal to 200 at an angle of 30, which is the maximum value. So usually vector diagrams we always draw between the RMS values. I mean we always draw vector diagrams for the RMS values. So here 200 at an angle of 30. So here is my V. I mean, you can put it as 200 over square root 2, or V is good enough, and 30 degrees is like that right there. And I of t, you have negative 60. So your I of t is going to be somewhere here, or I equal to 10 over square root 2 at an angle of 60 degrees. So the angle between these two must be 90 degrees. So this is the vector diagram for the given voltage and current parameters. I'll stop this video here. Thank you.